Welcome to Math TV with Professor V. In this video, we're going to look at solving equations and inequalities involving absolute value. So we have a theorem here that says that if A is a positive real number and U is any algebraic expression, then the equation absolute value of U equals A is equivalent to U equals A or U equals the opposite of A. So that's the theorem that we're going to use to solve all of our absolute value equations. Basically, when you drop the absolute value bars, you need to rewrite two equations. One where you have the original expression that was inside the absolute value bars equal to A, and then you put the word or, that same expression equals the opposite of A. And keep in mind, A has to be a positive real number. We'll talk about what to do if it's not. Okay? So let's look at some examples here. Before you drop the absolute value bars and rewrite the two equations, you need to always isolate the absolute value expression first, okay? All right, there's a good reminder. So now we're ready to roll. So example 1a, absolute value of 1 minus 2x plus 6 equals 9. So first thing I want to do is isolate that absolute value expression. So I'm going to subtract 6 from both sides, and now we have absolute value 1 minus 2x equals 3. Now I'm ready to drop the absolute value bars and then rewrite two equations. So for the first one, you don't touch anything. You just write 1 minus 2x equals 3. Then put the word or. Now your other equation, again, don't touch what's inside the absolute value. Never, never. 1 minus 2x, this is going to equal negative 3. And then from here on out, you should be pretty comfortable. You're just going to solve each of these equations, and we're going to end up with two different solutions. So isolating x in the first equation, we'll have negative 2x equals 2. Dividing by negative 2, I get x equals negative 1. Or here we have negative 2x equals negative 3 minus 1. That's going to be negative 4. If I divide by negative 2, I get x equals positive 2. So these are my two solutions. I'm going to put them in a solution set. Negative 1, 2. The order doesn't matter. They're not an ordered pair, so don't put parentheses around them. They're just two different x values that are solutions to this equation. All right? Good. Let's move on now to example B. We've got absolute value 2 minus x plus 7 equals 6. So what's the first thing we should do? Yes, subtract 7. You want to isolate the absolute value expression. So absolute value 2 minus x equals negative 1. Uh-oh, now I told you in the beginning, this number over here that the absolute value expression is equal to needs to be positive. And right now this guy is negative, which is a no-no. And stop and think about it. Is it possible to take the absolute value of some quantity and end up with a negative number? No, it's not, right? Absolute value takes negative quantities and it makes them positive. Worst case scenario, if this was somehow equal to 0, then it would be possible to have a 0 on the other side, but certainly not a negative number. So don't do anything else from here on out. As soon as you see there's a negative number on the other side, you could just say no solution. And we're done. I know, these should be your favorite ones. Okay, let's move on. Example C. Notice, we've got a quadratic expression inside the absolute value bars. Proceed the same way though, don't overthink things. So we're going to have here x squared plus 3x minus 2 equals 2, or x squared plus 3x minus 2 equals negative 2. Very good, very good. Okay, from here we're going to solve each of these quadratic expressions separately. So the first one I'm going to set equal to 0. X squared plus 3x. If I subtract 2, now I have minus 4 equals 0. Does that factor? It certainly does. Okay, that's good. So it'll factor into x plus 4 times x minus 1 equals 0. If I use the zero product property, then I can see I get x equals -4 or x equals +1. All right, good. Now, other equation, if I add 2 to both sides, notice now it cancels out entirely. So I'm just going to have x squared plus 3x equals 0. Don't let the fact that there's only 2 terms make you nervous. It's actually easier. To factor, you just take out the greatest common factor. So I can take out an x from both of these, and then you have x plus 3 left over. And then again, use your zero product property. Remember, when you have an x all by itself, that means x equals 0 is a solution, and then x plus 3 gives me -3 as a solution. So this time we come out with 4 solutions: -4, 1, 0, and -3. Ooh, I always feel so victorious when I have so many answers. I love it. Okay, last one of the absolute value equations is example D. Absolute value of x squared minus 2x equals absolute value of x squared plus 6x. Now, I know this is a little bit funky because we don't have a constant on the other side, but you would proceed the same way. So what you do is you write out x squared minus 2x equals x squared plus 6x, leave it alone. Or you have x squared minus 2x equals the opposite of x squared plus 6x. You'll still only be left with 2 cases when you have that absolute value expression on both sides of the equation. Either both quantities are the same or they're opposites of each other, okay? Good. Now let's go through and solve each of these equations. If I look at the first one, the x squared actually cancels out entirely. So I have -2x equals 6x. I could subtract 6x from both sides. -8x is 0. Divide by -8, so x is 0. That one wasn't bad. Let's see what's going on with this other equation. X squared minus 2x equals -x squared minus 6x. I can add x squared and add 6x over. So we have 2x squared plus 4x is 0. So only 2 terms. Let me factor out the greatest common factor, which is 2x, and then we're left with x plus 2. So setting each factor equal to 0. If you have a 2, that's not going to change anything. 2x still means x equals 0 is a solution, and then x plus 2 means x equals -2 is a solution. Okay, so let's put everything in the solution set. Notice I have 0 as a solution twice, so you don't need to be redundant and put it in there twice. Just once is enough. Everybody knows 0 is a solution, okay? And we're done. All right, not too bad, yeah? Now things get a little trickier when we're dealing with inequalities. You probably expected, right? Inequalities are always high maintenance little things. So here's our theorem. If A is a positive real number and if U is any algebraic expression, then you have 2 cases basically. If you have absolute value of U is less than A, that's equivalent to writing U is less than A and U is greater than -A. And the other scenario is if you have absolute value of U is greater than A, that's equivalent to U is greater than A or U is less than -A. I'll show you a good way to remember it that I always tell my algebra students. And then just remember, the words are very important. For one case, you're using the word and, the other one you're using the word or, and it does make all the difference mathematically. And means intersection, so wherever the 2 sets overlap. Or means a union, so you join up all possible solutions. And use that symbol U for disjoint sets if necessary. So I'm gonna first do like a little breakdown for you. And then we'll work on some examples because I want you guys to remember the 2 cases without getting jumbled up. So say you have case 1, you have the expression absolute value of x is, I'm gonna put a number, it'll make you feel better, greater than 5. Okay, first things first, the absolute value is greater than some number. So think of it as great or. You're gonna use the word or here. You're gonna drop the absolute value bars. The first inequality you write looks just like the original, x greater than 5. Then we're putting the word or because it's great or. Good, good. See, you like that? It's cheesy, but you're gonna remember. Okay, look, this is the same as the original, or in the second one, you do two things. You flip the direction of the inequality, and then you make that number negative. Two things just happened. Did you catch it? Flip, switch. Okay, that's case 1. Case 2, you have absolute value of x is less than 5. Okay, less than, and. You're going to use the word and. Okay, so same principle applies. First inequality is the same as the original. Then I'm going to put the word and, less than, and then you do two things here. Flip the direction of the inequality, change the sign. All right, now I want you to notice something about case 2 in particular. If we were to graph this, x less than 5 and x greater than negative 5, look what happens. X less than 5, so that would be here to the left, and x greater than negative 5, that would be, where's my minus sign? Get over here, minus sign. Open circle to the right, and means overlap, yes, intersection. Well, where's the overlap? It's right here in the middle, right here. So there actually is a shortcut way to solving these, the and ones, and it goes like this. You can just drop the absolute value, keep things the way they are originally, and then just slap another inequality sign on the other side and put the opposite of the number. And that matches the final solution after you figure out where the overlap, where the and, the intersection occurs. I call this the little sandwich compound inequality. So for case 2, when you have less than, then you can just go straight to this if you want, if your teacher lets you. If you were in my class, I would let you, okay? For case 1, though, there's no way to condense your solution. If you look at it, x greater than 5 or x greater than negative 5. I mean x greater than 5 or x less than negative 5. Excuse me, I misspoke. It would be like this, like this. Notice there's no intersection, right? That's why the word or is so important. If the word was and, it would be no solution. But since it's or, we could say the solution is from negative infinity to negative 5 union 5 to infinity. Okay, that's your answer in interval notation. All right, good. So now let's work through some examples, okay? And you should be fine afterwards. Solve each, I should say inequality, excuse me. I'll have a chat with my editor. Okay. Absolute value 2x plus 5 minus 2 is less than or equal to 5. So again, you're going to isolate the absolute value expression first. So we've got absolute value 2x plus 5 is less than or equal to 7. Okay, so from here, we could write 2x plus 5 is less than or equal to 7. And because the absolute value expression is less than 7, 2x plus 5 is greater than or equal to negative 7. But remember, this is the case where you could just write your little compound sandwich inequality from the get-go if you want, like this, and then just solve, and it'll be easier, less steps. So we're isolating x in the middle. I'm going to subtract 5, so we're going to have 2x is less than or equal to 2 and greater than or equal to negative 12, and then divide through by 2, so x is less than or equal to 1 and greater than or equal to negative 6. See, wasn't that nicer? And then I don't even have to think now where was the intersection. It's already cleaned up and ready to go. So closed circles, and in interval notation, we'll have brackets from negative 6 to 1. You know, they didn't say if they wanted interval notation, graph, set builder, so I'm just doing it all, okay? When in doubt, if you know something, show it. Show it. Show your teacher how hard you've worked, what you know. Okay, let's look at example B. Absolute value 1 minus 3x minus 4 is greater than negative 1. So first thing, what should we do? Yes, add 4, get that absolute value by itself. So we have absolute value 1 minus 3x is greater than 3. Great or, so I'm going to write 1 minus 3x greater than 3, or 1 minus 3x. Do two things. Flip the direction of the inequality, change the constant to a negative. All right, now let's solve each of these. So negative 3x greater than 2. Be careful here. I'm dividing by negative 3, so I have to flip the direction of the inequality. Or negative 3x is less than negative 4, so x is greater than 4/3. So these are our two solutions, or no, they're not two solutions. It's just both parts of the solution. So we've got negative 2/3 over here, 4/3 over here. X is less than negative 2/3, so open circle, shade to the left, open circle at 4/3, shade to the right. Let's write it in interval notation. You have to read from left to right. So first interval goes from negative infinity to negative 2/3 parentheses. And then when you need to connect it to another interval, then you put u and then 4/3 to positive infinity, like that. How was that one? Favorite one of the day? Okay, couple more. Example C. How shall we begin? Yes, let's subtract 2. So we've got absolute value 3x minus 7 is less than or equal to negative 1. Whoa, 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 whoa. We've got a negative number over here. Now let's stop and think. Is it possible to take the absolute value of something and it ends up being less than a negative number? No way. This is impossible. So that tells us there's no solution. We could draw out a sad little empty set. We could even draw a number line and refrain from shading or plotting a single thing. Just leave it there in its loneliness. Okay, that's it. Actually, I like it when that happens because then there's no work to do. Okay, example D. Don't get too excited seeing the negative on the other side and thinking it's another no solution, because the absolute value is not isolated. We got to divide through by that negative. And in so doing, don't forget to flip the direction of the inequality. So we've got absolute value 1 minus 2x is less than or equal to positive 3 now. Okay. You could write two inequalities, or we could just jump straight to the little sandwich compound inequality. Okay. Both, this should face the same way, and these should always be in the same direction. Sometimes I see students doing wacky things. It's okay. Just stop it now. We're going to subtract 1 from everybody. And then let's see, what do we got going on? Negative 4 less than or equal to negative 2x less than or equal to 2. And then let's divide by negative 2, but with the utmost care, because when we divide an inequality by a negative, we got to flip the direction of that inequality, yes? Yes, so x is greater than or equal to negative 1 and less than or equal to positive 2. Let's graph it. So here's negative 1, here's positive 2. Closed circles at both, boom. And then in interval notation, brackets, because we're including those endpoints. Okay, are we getting a little bit more comfortable? Yes? No? Let's do a few more then. Okay, example E. This time we have to write two separate inequalities because this is greater than 1. So here we go. We've got 2x minus 3 over 2 plus a third is greater than 1, or 2x minus 3 divided by 2 plus 1/3 is less than negative 1. Let me make my little boundary right here. Okay, let's solve each. I know there's fractions, but really you don't need to have a meltdown. I mean, some students go into panic mode unnecessarily. Can you subtract 1/3 from 1? 1 is 3 over 3. Minus 1/3 is 2/3. Look at that. Can you multiply both sides by 2 now to get rid of that denominator? So 2x minus 3 is greater than 4/3. Add 3. 3 is 9/3. So 2x is greater than 13/3. Look at us just breezing through. Divide by 2. That's the same as multiplying by a half. So x is greater than 13 over 6. Okay, look at, we survived. Same thing over here. 2x minus 3 over 2. Just be careful. Negative 1 is negative 3 over 3. Minus 1 over 3. This is negative 4 over 3. Now multiply by 2. You're going to multiply always just the numerator, so that's negative 8 over 3. Add 3, which is 9/3, plus negative 8/3 is positive 1/3. And then divide by 2, which is the same as multiplying by a half, that's 1/6. Okay. How painless. So let's see here. X is less than 1/6 or greater than 13/6. Do you see how I'm not stressing about the number line? I'm only putting the two values of interest, 13/6 and 1/6, on there in a way that makes sense, and then that's it. I'm not drawing all these tick marks. X greater than 13 over 6. Open circle to the right. X less than 1/6. Again, open circle to the left. Okay, see, this time the word or is so crucial. So the solution is going to be the union of these two intervals. So we'll go negative infinity 1/6 union 13 over 6 to positive infinity. Voila. Okay, last one like this. 1 minus absolute value x minus 5 is less than or equal to 3/2. We got to get that absolute value by itself first, right? So let's subtract 1. So negative absolute value x plus 5 is less than or equal to 3/2 minus 1 is positive 1/2. Now I'm going to multiply through by a negative or divide by negative 1. Same thing. I have to flip the direction of the inequality, and this is now negative 1/2. Oh, we've got a negative number over here. So let's stop and think. Is it possible to take the absolute value of something and it comes out greater than negative 1/2? You know, it's always true. Anytime you take the absolute value of some quantity, no matter what's in there, it's always going to come out positive. Worst case scenario, it's going to be 0. 0 is greater than negative 1/2. So there's no way this won't be true. What does that mean? If something's always true, then any number that x could take on, any real number, will work to satisfy this inequality. So your solution is from negative infinity to infinity. How would you shade it? Oh, you would just get a number line. Let's put 0 on there just so we know it's a number line. And then you just shade in the whole thing. Everybody's good to go. Everyone's a solution. How fabulous. Okay. Last two exercises are similar to what we went over at the end of the last lesson. Here's an extra page just for you to think about everything that's happened so far. Okay, we thought about it. Now, example 3. We have absolute value x plus 2 is less than 5, then a is less than x minus 2 is less than b, and we have to find a and b. So to start off, let's rewrite this inequality without the absolute value. Notice they wrote absolute value x plus 2 is less than 5, less than, so you could just jump straight to that little sandwich compound inequality situation that we love. I need x minus 2 in the middle. Let's get there in baby steps. First, let's get rid of this 2. How's that sound? You could just jump straight to the final answer, but let's not be too aggressive. So -7 is less than x is less than 3. I need x minus 2 in the middle. So subtract 2 one more time. Okay. And we're going to end up with -9 is less than x minus 2 is less than 1. Woo! So there we go. That's A. That's B. I'll write it nicely. A is -9. B is 1. And if you were feeling comfortable with this kind of problem, you could have just from the get-go subtracted 4 and gone straight to here. Okay? But, we can take it in steps. It's not like it took forever. Last one. Absolute value x minus 3 is less than or equal to 1. Then A is less than or equal to 3x plus 1 is less than or equal to B. Okay, so same idea. Let's start off rewriting this without the absolute value. So -1 less than or equal to x minus 3 less than or equal to 1. Let's just get x by itself first. So add 3 to everybody. We're so equitable. Okay, so this is 2 less than or equal to x less than or equal to 4. Now let's try to match it. I need 3x plus 1. So first, let's multiply everybody by 3. Okay, so then we have 6 is less than or equal to 3x is less than or equal to 12. And then now let's add 1. And we have 7 less than or equal to 3x plus 1 less than or equal to 13. There's A. There's B. These are kind of fun, huh? If you don't think so, I'm sorry. I'm over here having a math party. Okay. So that concludes the lesson. The next video for this series is going to be on applications. I'm sure we'll have a roaring good time. Give the video a thumbs up, subscribe if you haven't already, and stay tuned, guys. I got lots more uploads coming your way. Bye.